Alright, so in today's lesson we are doing word problems. We're doing word problems that involve us calculating the vertex and applying that vertex to the context of the problem. Alright, so in this first example here, the area of a rectangle is given by the relation A equals negative 2w squared plus 72w, where w is the width and A is the area in square centimeters. So notice in this equation right here, we are graphing A versus W, okay? So that means when we actually graph this, we're not actually graphing it, but just to understand what the vertex represents, and that's the hardest part of these questions, you're graphing area, A, versus width, all right? So when you have your parabola, and we know it's opening down because A is negative 2, so when you have your parabola like this, you're going to have a vertex. And that vertex typically has x and y coordinates, but we're not dealing with x's and y's here. We are dealing with width on the horizontal axis and area on the vertical. So when we find our vertex, you are really finding the value of the width that results in the maximum area. So in this first problem here, it's asking us to determine the max area of the rectangle. So what is that looking for? It's looking for the k value, the k coordinate of the vertex. So I know we've done lots of problems like this, but let's give a very clear step-by-step process on how to do that. Well, step one, we need to factor this. And you factor it so you can find your x-intercepts. To find x1, x2. You might not have two x-intercepts, but you're finding your intercepts. Step 3, actually I'll put that, to find x-intercepts. Step 2, once you find the x-intercepts, use the formula where your axis of symmetry, which is this value right here. This is the AOS, okay? It's the coordinate that cuts the parabola in half. It's the x-coordinate. This is your AOS. So step 2 is using the AOS, which is the formula, taking your two x-intercepts, adding them, and dividing it by 2. And the last step, step 3, is once you find the AOS, which is, again, go back to your picture, it's the x-coordinate, or if you have an equation that relates A versus W right here, you just sub the AOS in for these values here, which the AOS is equal to a width. It's a width value. And you calculate your area. So step 3, use the AOS, all right, which is a width, calculate the area. Okay, let's go through it. So step 1, we need to factor. We have our equation, which is area equals minus 2w squared plus 72w. Well, factor this. So if you notice, you can take a negative 2w out from both terms. That would result in negative 2w, leaving you with a w here, minus 36. So your two factors are, or your two x-intercepts are negative 2w when that equals 0, and you have your other one when w minus 36 equals 0. So your first one, divide both sides by negative 2, you will get w equaling 0, and bring the 36 to the other side, you get w is 36. Okay, there are your two values, and let's call that w1, w2. Those are your two intercepts. And just let's put that to a picture. What that means is that you found a width right here at 0. You found a width right here at 36. All right, those are your two x-intercepts, 0 and 36 centimeters. Step 2 says use the axis of symmetry. Axis of symmetry, take your two x-intercepts, add them up, divide by 2. So step 2, we have W, or AOS, our axis of symmetry, is W1 plus W2 all over 2. So you take your first one, 0, add your second one, 36, divide by 2, you're finding the halfway point between them. You would find at 18, you have your halfway point. So on your picture, that means right here, this is 18, halfway between 0 and 36. That means your x-coordinate of your vertex is 18. Use this value to calculate this, because this is W. This is your axis of symmetry, which we calculated. But remember, that's also your W. It's equal to whatever is on the horizontal axis. So in this case, we're calculating width on the horizontal axis. So that is W equaling 18. All right. Step 3. Well, we have our formula, area minus 2 W squared plus 72 W. So sub W equaling 18 and calculate your area. So area is minus 2, 18 squared plus 72, 18. You get, I'll use my calculator actually because I don't know 18 squared in my head. 18 squared times negative 2. You get minus 648 plus 72 times 18, 1296. And finally, minus 648, 648. And our units, I believe, are centimeters. Centimeters and centimeters squared, yeah. So 648 centimeters squared. That is the vertex. That is the area right here. That means this right here is 648. So at a coordinate of 18 on the width, you get 648 on the area. That's what makes these problems hard. It's just honestly just understanding what it is you're actually calculating. You're not just calculating x and y coordinates anymore. They're word problems. So therefore, the max area is 648 centimeters squared. What is the width needed to produce this maximum area? Well, if you think about it, this width right here producing the maximum area, that's the x value of your vertex. So the width needed to produce the maximum area, we've already calculated it. It was this value right here. So we have a vertex that has coordinates 18 and 648. That is this value right here. That's what this question's asking. So therefore, the width needed to produce the max area is 18 centimeters. And again, width, I know it says centimeters right here. So, question 2. All right, in this problem right here, again, these are the most common types of questions. We're going to be dealing with some sort of dimension problem. We're going to be dealing with, in this case, a revenue problem. And you'll see third later is some sort of projectile problem. And they're the most common ones you'll see in the textbooks, all right? So revenue type questions, it's really the hardest thing is just setting up that initial equation, okay? Reading the problem and creating the equation. So question 2, or example 2, sorry. Joseph sets the price at a hardware to-go store. His research shows that an increase of 10 cents in the price of a package of batteries causes a drop in sales of 10 packages per day. The store normally sells 600 packages of batteries per day at $4.95 per package. All right. What is the maximum revenue Joseph can expect on the sale of batteries? So if you think about these problems, revenue, all right, what is the maximum revenue? Well, let's get an idea of what revenue actually is. If you sell 600 packages at $4.95, well, your revenue would be 600 packages multiplied by $4.95. All right? Whatever that equals, that is revenue. It's your basic formula is revenue equals number of items sold times the price of the items. And just think about it for a second. Let's say you owned a lollipop or a lemonade stand, okay? If you only sold one lemonade, all right, and it was $10 for that lemonade, crazy expensive, that's probably why you only sold one, well, your revenue would be $10. You sold one lemonade for $10. One item sold at a price of $10. If you sold two lemonades for $10, you'd be at $20, okay? So it's this number of items sold times price of items. Well, what is the maximum revenue expected on sales? Well, let's first define some variables here, okay? Because if you think about the previous problem, variables were defined for us. W is the width, A is the area. In this problem, nothing has been created. No variables have been defined. So let's say, let R represent the revenue. And revenue is money, so it has units of dollars. All right, and we're going to need another variable, but first let's set up the problem and then we'll define the variable, okay? Well, our revenue, our R, is equal to number of items sold. Well, Joseph typically sells 600 items, and he sells these items for $4.95. Items sold, price per item. Well, this whole part right here, this is what makes it hard. The research shows that an increase of 10 cents in the price of the package. So meaning that if he typically sells them for 49.5 cents, and if he increases it, so adding 10 cents, that means he would sell 10 less packages per day. So 10 less number of items sold. So minus 10. But you don't just leave it there, because how many times does he change that 10 cents? We don't know. So that's why you call it X. And there's our second variable. We do not know how many times he's changing the price. So let X represent the number of changes, okay? So think, if X was 2, okay, so if you did 2 changes, well, you'd be going up 20 cents in price, but you would sell 20 fewer batteries, all right? And then you'd multiply them and get your revenue. We are trying to find the max revenue. So we are trying to find, if we graph this, we are graphing now revenue on the Y, revenue versus number of changes. Okay, so number of changes is down here. And this is given the variable R, measured in dollars. And this is given the variable X, all right, which doesn't have units because it's just number of changes. You would have some parabola where this would have a maximum, that would have a maximum number of changes, X, with a maximum revenue. Okay? So in this first problem, what is the maximum revenue? Once again, we are looking for the K value. So it's the same process as above. It's the same steps. You have a factor, a quadratic equation, factor it. Find your AOS. Use that AOS to find the K value or the maximum. All right. In the previous problem, it was the area, but in this problem, it's revenue. All right. So step 1, factor it. Well, it's super convenient. We actually already have it in factored form. So just take this bracket and set it equal to 0. All right. So the hardest part of this problem was just you creating these equations. Once you have the equation, the process is the same, and you will see that over time. It's just it's a pattern. It's like an algorithm you use. So take this 600, bring it over to the other side. Minus 10x equals minus 600. Divide this by minus 10. Divide this by minus 10. These cancel. You get x is equal to 60. That is x1. That is your first x-intercept. Do it again for this bracket this time. 494.95 plus 0.1 x, set this to 0. So first step, bring the 495 over. So 0.1 x is negative 4.95. Divide both sides by 0.1. So these cancel. Oh, sorry, divide both sides by 0.1. All right, so you get x is equal to minus 49.5. There's x2. That's your second x-intercept. Perfect. Now move on to step 2. Step 2 says use these values, calculate your axis of symmetry. And again, the axis of symmetry is going to represent the number of changes required to give us the max revenue. So in this case, we're going to get x1 plus x2, divide that by 2. So that would be 60 plus negative 49.5, divide this by 2, you would get 5.25. So that means the number of changes required is 5.25. This right here, this coordinate right here is 5.25. Step 3, use that value to now calculate the max revenue. So you have an equation. R is equal to 600 minus 10x 4.95 plus 0.1 x. Well, this is x. This is the number of changes. So take this value and sub it in. Sub x 25. So you get revenue equals 600 minus 10 times 5.25. Close that bracket. 4.95 plus 0.1, 5.25. Close that bracket. Let's do our math. I'll need a calculator. So this first bracket, 600 minus 10 times 5.25. This first bracket evaluates to 547.5. Multiply that by 4.95 plus 0.1 times 5.25. This one would be 5.475. Take those and multiply them now. 547.5. You get 2,997.56. Stop at 2 decimal places because this is in units of dollars. All right. So this is the max revenue. This is the max revenue because it's at the y coordinate of your axis of symmetry. Or sorry, it's at the axis of symmetry. It's the y value at your axis of symmetry. So this right here is 2,997.56. That's what you just calculated there. So let's create a therefore statement. Therefore, the max revenue is 2,997.56. Well, how many packages of batteries must be sold to generate the revenue? What price will generate the maximum revenue? So this first sentence, this first question, this whole thing, how many packages? Well, that is number of items sold. So that was your first bracket right here. That's this bracket. So number of items sold is 600 minus 10x equals. Okay, or actually, let me do that right. Number of items sold, number of items, actually it might be easier if I just do this. Bring this up here. Number of items sold is 600 minus 10x. So that is 600 minus 10. We had 5.25 changes. So 600 minus 52.5. So you get, can't do that in my head, so I gotta use calculator. 547.5. All right, well, let's round that up because you can't sell half a package. So roughly we're rounding 548 batteries sold. All right, packages of batteries. So therefore 548 batteries packages, or packages of batteries. Therefore 548 packages, I don't know why it's so hard for me to say, of batteries sold. Okay, well, part 2 of that same question, what price will generate the maximum revenue? Well, the price of the item sold is this bracket right here. So, price of items is equal to $4.95 plus 10 cents for every change that you do. So this is equal to $4.95 plus 0.1, and we did 5.25 changes. So use your calculator again. 4.95 plus 0.1 times 5.25 is 547.5. And again, this is in units of dollars because it's price. So this would be units of dollars. So you need to round. So round to 2 decimal places. $5.48 would be your final answer. So therefore, the price that gives the max revenue is $5.48. Okay. Third example, again, these are your most common types of examples. We're going to do some sort of projectile right now. A baseball is thrown from the top of a building and falls to the ground below. The height of the baseball above the ground is approximated by the relation h equals -5t squared plus 30t plus 35, where h is the height above the ground in meters and t is the elapsed time in seconds. Great. Variables are defined. We do not need to do that. So how high is the building? Well, if you think about the context of this problem, you have a building. Oh, let me draw it a little smaller, give myself some room. You have a building, right? You are throwing a ball off the building, and it is going to come down and hit the ground, So, how high is the building? Well, if this is my building, I want this distance right here. I want this height. And how long this ball is flying for? Well, this is measuring in time. So if you think about it, this ball is going to fly in the air for time seconds, right? Well, when you first throw the ball right here, the time in which you throw it, that has a value of 0 seconds. So how high is the building? Well, if you're measuring the height of the building versus time, all right, so height and time, this is when t equals 0. So you have h of t equaling minus 5t squared plus 30t plus 35. So these are t's. Well, you sub in 0 for t, 0, minus 5, 0 squared, 30, 0, plus 35. This term goes to 0, this term goes to 0. So really, it's just this. So there, the building is 35. So therefore, the building's height is 35. But 35 what? We are measuring it in meters. Meters. So the building's height is 35 meters. When does the ball hit the ground? Well, it hits the ground right here. So if you think about what that is, that's going to have a coordinate, some time value, which we're looking for, because when, that's our unknown, does it hit the ground? Well, the ground has a height of 0. You're on the ground. You have no height. So if you have an equation, h of t is equal to minus 5t squared plus 30t plus 35, we are looking for the value when h of t equals 0. This represents the ground. There is no height. Height is 0. So it's 0 equals minus 5t squared 30t plus 35. We have a quadratic set to 0. So whenever you see that, you have to factor. You're solving a quadratic. It means factor, okay? So 0 minus 5, take out your GCF first, t squared minus 6t minus 7, all right? So we need two numbers that multiply to give us negative 7, and, sorry, it's a multiply, and same two numbers need to add up to give us minus 6. Well, that would be minus 7 and 1, minus 7 and 1. So this is a simple trinomial with an a value here of 1, so we can just quickly factor. It's 0 equals minus 5 t, and your factors were plus 1 and t minus 7. Well, when does the ball hit the ground? You're looking for time, t, so you have 1 when t plus 1 equals 0. Bring that over. It would hit the ground at t of negative 1 seconds, which is not possible. Time can't be negative. Or you have t minus 7 equaling 0. Bring the 7 over. T equals 7 seconds. So this one can't be negative. Time can't be negative. So therefore, the ball hits the ground. At 7 seconds. That means on your graph right here, this right here, 7 seconds. This represents a coordinate here of 7. Determine the maximum height that the ball reached by the ball when it and when it reaches the height. Sorry, okay. So we need the max height and when it reaches that height. Okay. Well, let's think about it. If you're graphing height versus time, once again, you're going to have a maximum right here. That's going to have a time on the x-axis, the time, which is your axis of symmetry, right here, and it's going to have a height. So essentially, this problem is saying, what is your vertex? Because it's asking for both the time and the height. Well, getting this value, that's your AOS. So take your two intercepts, which we calculated from above, take them, divide it by 2. Okay, so that is just -1 plus 7 divided by 2, which is 6 over 2, or 3 seconds. So that is when the ball reaches the height. All right, well, the second part of the problem, so this is t equals 3 seconds. So now just take that value and sub it into your equation. If you have h of t equaling -5 t squared plus 30 t plus 35, well, now you're calculating the value of your height at 3 seconds. What is the height when you're at your maximum x coordinate? -5, 3 squared plus 30, 3 plus 35. So this would be -5 times 9 plus 90 plus 35. I'm just going to use my calculator. So that first term would be 45, or -45, sorry, plus 90 plus 35. We would get 80 meters. So therefore, so actually, before we do therefore, just give it context. Your vertex is at the coordinate 380. That means, in our picture up here, at 3 seconds, you have a height of 80 meters. So 3 and 80. All right. So therefore, max height of 80 meters at 3 seconds. And there we go. That's for today's lesson. All right. There's our homework, and I'll see you in class.